Hello, everyone. In this video, I will give a guide and tips for chapter 9 of my Java book. In chapter 9, we begin to introduce object-oriented programming. So we'll begin with objects and classes in chapter 9. So first, in the introduction section, so we're going to lay out the motivation and why we need to have object-oriented programming. So you please read this. And so this is for developing large software system, for developing reusable code using object-oriented programming. So now we get into this section for defining classes and objects. So how we defining classes for objects. So this is in here, and read this section. So you look at objects have states and behavior. So you're going to define this in the corresponding class. A class is like a template for objects. You use class to create objects. And objects is also known as an instance. All right, so this is the UML diagram and to picture a class, and these are the objects of the class. Here the class is a circle, and so you have the objects, and so this is the 1, 2, and 3, and the object has this property. So this is radius. So this is radius 1, this is 25, this is 125. Now, this is the class to define circle. So here is a class circle and the radius and the constructors. So this is we're going to use these constructors to construct the objects. So these are the behaviors. So use the methods. You can get the information from the objects, and you can change the value in the objects. All right, so this is the UML diagram for the class. So here's the class circle, and this is the radius, and this is the constructors, and this are the methods. So here, these are the objects for this class circle. All right, so, and here is the how you define a class and creating objects using an example. So put all this into the code. So now you're going to see here, we have one file with 2 classes. So this is the circle class here, and this is the test circle. So how are you going to test the circle? Using this, the main method in the class. So we put these 2 classes into one file, and there's only one public class. So that's the one we're going to run at, test circle. All right, so this is test circle, and so you can see here, and this is 2 classes in one file. When you compile it, and you're generating 2 classes. So the circle class, and this is test circle class. This is the public, so you're going to run from this class. And you can combine these 2 in one. So you have a circle and put the main method in the circle class. So the rest in the circle class is here. So this is one class, and you can have main method in this class circle. Another example here is the TV. And so see how we model TVs. You create a lot of TV objects from the TV class. So TV has channel, volume level, and on and off. So this is on and Boolean value, true or false, indicating is on or off. All right, so this is the test code, and for the TV class, in the main method, we create 2 TV objects and invoke the methods to manipulate the TV objects. All right, so this section is on constructors. So what are the rules for the constructors? So please read this, and the constructors. Constructors are special methods and with specific rules. you need to follow. So here's accessing objects or reference variables. So you need to a reference variable to reference the object, and then using the reference variable, you can invoke the object's methods. So here, this is here the to declare a reference variable, and this is the object reference variable. Here's the class name. So this is the circle is the type is the circle. The class is the class. It's an object type variable. So this is my circle, and now you create my circle object, assigns reference to my circle. So now you can use this my circle and this to access its data field and invoke its method. So here is this is what we do in this section. Accessing an object's data and methods. So you can reference data fields. So here's so this is the class student, and you can have a so here's the is major. So this is the Boolean type. So here's the Boolean type, and so you have the default values here for this, the data fields reference. So here's a name. If you don't assign anything here, and this, it's a null value. So all the others here, primitive data type, numeric type, you get default value 0, and the Boolean, you get default value is false. And this is the gender is character, so that's the first Unicode. So here's a test program, so you can display and thus see the values here displayed. So the default value. So please note that data fields you define in the class, they have default values, but local variables have no default values. So here in the main method, you declared int variable x has no default values, and here is y is a string, so y has no default values. All right, so look at the difference between variables of primitive data types and reference types. So, and this is int I has a value of 1. So this is C is a circle type as reference and reference to an object. So this, now what's the difference when you do assignment? You assign a J to I, so you just copy the value of J and to I. So both now are 2. So what happens if you do this C1 and C2 and you assign C2 to C1? So the reference value of C2 is assigned to C1. Now C1 and C2 points to the same object as C2. And the so this is what happens. And this C1 here, the previous object referenced by C1 is now becoming a garbage. It's not referenced by any variable, so that's the garbage. Garbage is automatically claimed, reclaimed by the Java virtual machine. All right, so here we look at examples of using classes from the Java library. There are many classes in the Java library. We use all these classes to build our applications. So here's some examples: the date class, the date, and this is the random class. So we already have the random method, mass.random. So there's more things here you can do with random, and this is more. Here is using the random class. And this another one here is point2d. So you have the points. So you use point2d to model it. And here using point2d, you can get distance of the 2 points. So you can get other features like midpoint between 2 points. All right, next, we're going to look at static variables, constants, and methods. So there's two things: instance variables, methods, and static. And instance belongs to each instance. Static shared by all the instances. So that's the difference. And here, we're going to look at an example here. We have this is the class so-called. We're going to add one data field. It's called number of objects. A number of objects is to track the number of total objects of the so-called class created in your program. So that is shared data field for all the so-called objects. So this UML diagram is underlined. So here's get a number of objects. So you can see this. And so let's look at the example here. Now, before you create any objects, so the number of objects is 0. Now you create one object, so this number of objects becoming 1. So here, this is the so-called, its radius is 1. So now so-called radius is 2 as another object, you instance 2. So now the number of objects become 2. So now see the difference here. So if you go back to the previous one, this is 1. So now is 2. All right, so here, this is instance. You change this 1 to 9. So this is fine. So this is instance, and this is 2. So this track number of objects. And when you declare it and you use static, the keyword, so static int number of objects, and static int get number of objects to return the number of objects. So we also have constants, never changes, so they are static. So static here, and you can have a final static double, and here's pi, the value of pi. So so for this, and here is static. So you look, you write a static here. This is a test program, and using the static members of the class here. So how you reference here, static here. So this, the number of so-called objects. So now here is, you see the number of objects, right? But when you write it, so you have to use the class name. Here is so-called dot. So this is you look at this is so-called dot. Here is for this so-called, and this is so-called dot, number of objects. Or use get number of objects. Same thing here. So now, if you look at this answer here, I have this is here you can use C1 dot number of objects and C2 dot number of objects. So from each instance, you can directly access static data fields, but a better way is to use the name so-called dot and so-called dot, because from here, clearly you can see this is static member. So if you just write a C1, it's correct, but it's confusing. It might be mistaken as an instance data field. All right, so we're going to move to the next is look at the visibility modifiers. In this section, visibility modifiers, we're going to introduce the private member. So private data fields and private methods. Private data fields should, in almost all the cases, except some rare situation, you need to make all the data fields private. So to make it private is you're going to protect your data and also make your code easy to modify. So please get into this section and see why, and this is the case. This is true here, the private data field, and make your code easy to modify and also protecting your data. So this is visibility modifier. All right, and then we're going to use the private data fields. Now, if you want to make your data field available for access and to see it, you can use a get method. If you allow your data field to be changed, provide a set method. So it looks like kind of redundant. To make it a private, you have to provide this two methods, but this is for easy to maintain your code. So you later on, if you make some changes, and you only have to modify the code in this methods, get and set methods. So your the contract of your class is not changed. So that make your code, the entire ecosystem of the code is easy to maintain. All right, so this is the data field encapsulation, is to make your data fields private. Now, look, read this section, passing objects to methods. And this is the section using array of objects. And you can have array of objects. So here, like array of 10 circle objects. So each object is a reference to another object. So this is the array. So this array reference variable. All right, so look, the objects, if the contents of the objects cannot be changed, so this kind of objects are called immutable objects. So please study this section, see how we define the immutable objects and how we define so-called shallow immutable. So this is in this section, immutable objects, and their corresponding class is called immutable class. Here's the scope of variables in the context of class. And so look at the scope of variables now. And there's one thing is a this reference. So this refers to the calling object itself. And so for example here, you have this. So here, what is radius? A radius is actually this. It's when you use this, invoke this get area, you have object to invoke it. So that is the object, is this calling object itself. Now this can be omitted. So you can omit it just writing this, the return radius times radius. So explicitly is this dot radius. Okay, so that's one use. Another use is you have to use this is if you have a method like this, set radius. So this is the same name as your data field. So you have to use this dot radius to refer to this. If otherwise, this would be incorrect. You're going to assign radius to radius. So this is so another use here. Let's look at there's one more use is as a constructor here. You can invoke the here is circle, and this is the NOI constructor. You use this and to invoke another constructor in the same class. So this is here. So what is this one? This dot radius is here. So that's referred to data field. And here is for the constructor. All right, that is all for this chapter on objects and classes. Thank you for watching. Goodbye.